In the last chapter 2, we discussed about how do we solve an ordinary first order ordinary differential equations. Okay, so we discussed the separable of variable method. We discussed a linear differential equation. Okay, we also discussed the exact equation, Bernoulli's equation, and the solving equation by substitution, homogeneous equation, non-homogeneous equation, all those type of equation, linear, non-linear, all those type. Okay, and also we discuss about what is the necessary condition for a differential equation to have a solution. Okay, so on this chapter 3, we talk about the system of two first order ODEs. Okay, so before we start the system of two first order ODE, we will talk about system of two linear equations. What are the system of two linear equations? So this type of equation that we discuss in the college algebra also, we know how to solve these type of equations, right? We try to cancel either x1 or x2 by multiplying by some numbers. Okay, that was the elimination method. And we also discuss about the substitution method, right? Elimination method. In the elimination method, we try to cancel one of the variable, either x1 or x2, by multiplying some numbers. So what was the substitution method? Substitution method is, so in the substitution method, what you do is you try to solve this first equation by x1, and then you will get b1 minus a1 to x2 divided by a11, and then you replace that x1 by that value, substitute that by that value, and then solve for x2. That's what we do, right? But we are focusing here on the third method called matrix method. Okay, so matrix method. In matrix method also there are several different methods to solve a pair of differential equation. Okay, so the first method, first of all, I want to talk about what do you mean by matrix. Okay, so matrix is the arrangement of numbers in a rectangular form, right? So it can be square form or a rectangular form. For example, so matrix A, let's say we denote matrix by usually the uppercase letter. And then we close the matrix by, let's say, A, B, C, D. This is a rectangle, right? Rectangular form. So this is a matrix. So another matrix you can think of like 1, 2, 3, 4, 5, 6. Okay. So this matrix has two rows, first row, second row, and then two columns, first column, second column. Okay. So on this matrix there are two rows, first, second, and then three columns. You see that? So there are three columns. Okay, and then two rows. The next thing that you need to know about a matrix is the determinant of a matrix. Okay, for example, A is a square matrix, right? For any square matrix, we can find out the determinant. So the determinant is for 2 by 2. A is a 2 by 2 square matrix. Now the determinant of A is denoted by that two bars around A. Okay, so you can write like it is like absolute value sign. So how do I find out that? This is basically A and then B and then C and then D. That's what we had. Instead of bracket or parenthesis, we write a vertical line here. Okay, that covers all the rows. So how do I find out the determinant? Is you basically what you do is you multiply this with the diagonal, and for the another diagonal you do the negative multiplication. Okay, this regular diagonal or this diagonal is the positive multiplication, and then this is the negative multiplication. So it will be like AD minus BC. Why minus BC? Because this times that is BC. Since this is that direction, so we do the negative of that. So negative BC. Okay. So this is the determinant of matrix A. Now we cannot find out the determinant of matrix B because it is not a square matrix. Why it is not a square matrix? Because the size of this matrix is 2 by 2. That means 2 rows and 2 columns. But size of this matrix is 2 by 3. So they are not equal. The number of rows and number of columns are not equal. So it is not a square matrix. So we cannot find out the determinant of B. Okay. So the next thing I want to do is how do I solve this pair of linear equations by using matrix method. Okay, so number one method we use is Cramer's rule. Cramer's rule. What you do under Cramer's rule is you write down the coefficient of these equations. What you do is you do A11, A12, and then colon, and then B1. Similarly, A21, A22, and then B2. This is given equation in the matrix form. Okay, now you see that why do I write A11, A12, A21, A22? This has a reason, right? See, this A11 means first row, first column. That's why 1, 1. This is the first row, second column. 1, 2. Similarly, this is second row because this is first row, first column, and second row, second column. You see that? So B1 and B2 there. Now, what we do is you define D as the determinant of the coefficient only. So it will be A11, A12, and then A21, A22. This is the determinant of the coefficients only. These are the coefficients of x1 and x2. Similarly, you define D1 as the coefficient of the determinant, but the first column is replaced by that column of constant. That will be B1, B2, and then A12, A21, A22, right? And then similarly, you define D2 by that coefficient, determinant of the coefficient, but the second column, because this is 2, second column is replaced by B1, B2. So it will be A11, B1, right? And then A21, B2. Okay, so this is the determinant of the coefficient only. This is the determinant of the coefficient with first column replaced by the coefficient of constant, and this is the coefficient of the matrix of coefficient with second column replaced by that B1, B2, the column of constants. Okay, now how do I define x1? Because our goal here is to find x1 and x2, right? X1, X2, that's what our goal is. Now how do I find out that? Is x1 is given by D1 over D, and then x2 will be D2 over D. That is the formula, and this method is called Cramer's rule. Okay, so what is this one? This is basically this multiply positive A11, A22 minus A12 times A21, right? You can write that one. How about this one? This will be BA22 minus B1 A22 minus B2 A12, right? Similarly, this one will be B2 A11 minus B1 A21. That's what you do, right? Because these are the positive multiplication, these are the negative multiplication. Positive, negative, positive, negative. So this is how you find out the values of x1 and x2. Okay, guys. So the next thing you see is a theorem, and then we will talk about in which condition this equation has a solution. Do you remember that in a college algebra, the pair of equation can have at most 3 type of different graph, right? One graph is these two equations intersect at a point, right? And another graph is they are parallel, and another graph is they are coincident. You see that? Do you remember that? So what was the first condition? First condition is these two equations. The first situation could be these two equations, they intersect at a point, and that is the solution. Another possibility can be these two equations, they are parallel to each other. And another possibility is these two equations are basically the same equation, though they overlap. Okay, so this is called consistent and independent, meaning if these two equations have only one intersection point, then it is called consistent and independent. This one is called inconsistent because they are not cancelling, they are not meeting at a point, their graph does not intersect. And this one is they are overlapping, meaning that they meet at infinitely many points. We call consistent and dependent. This is consistent and independent. This is inconsistent, and this is consistent and dependent. So the theorem says that the system of this linear equation has a unique solution if the determinant of the coefficient, that determinant D, is not equals to 0. This is how you can check if it has a unique solution. Unique solution means consistent and independent. Okay, when does this system is consistent and independent? Is if the determinant of the matrix D of coefficient is non-zero. If that value is 0, if D is 0, then either system has no solution, okay, or there are infinitely many solutions. So this is called the Cramer's rule. Okay, guys. So the next thing that we want to do is we want to use inverse matrix method. So that is the another method. Number 2 is inverse matrix method. Inverse matrix method. First of all, I want to define what do you mean by a singular matrix. Okay, so let me write definition of singular matrix. Singular matrix. So we say a square matrix is called singular if the determinant of A is equals to 0. So if the determinant of A is 0, we call singular matrix. If the determinant is non-zero, then we call non-singular matrix. Okay, so singular and non-singular matrix is depend on the determinant. So the matrix must be square matrix, otherwise you cannot find out the determinant. Okay, so the next thing what I want to do here is, how do I find out inverse of a matrix? Okay, definition. Let A be a 2 by 2, means 2 rows and 2 columns, 2 by 2 square matrix. Okay, if A is non-singular, then the inverse of matrix A is denoted by A inverse. This is the notation, A to the -1. Okay, so if A is a 2 by 2 matrix and if it is non-singular, if the determinant is non-zero, okay, so singular means determinant 0 and non-singular means non-zero. If the determinant of A is non-zero, then there is inverse of that matrix, and it is given by 1 over determinant of A times matrix of cofactor. Matrix of cofactors. Okay, for example, how do I find out the matrix of cofactor? For a 2 by 2 matrix, the matrix of cofactor is you swap the diagonal elements, and then you change the sign of the other diagonal elements. Okay, the main diagonal you swap the values, and the other diagonal elements you change the sign. So for example, let A equals to A, B, C, D is a non-singular matrix. Suppose A equals to A, B, C, D. It is 2 by 2 matrix, right? Suppose it is a non-singular matrix, then A inverse will be like this: 1 over determinant of A times swap the diagonal elements. So it will be D and then A, and then other diagonal element you multiply by negative sign. That means you change the sign of the other diagonal elements. So this is the inverse of matrix A here. Okay, so basically you swap those two and then you multiply by you change the sign of that. Okay, guys. Now, how do I use a inverse matrix method to find out the solution of a differential equation? That's the next thing I want to talk here. Suppose that you have, let's say, two linear equations. Okay, two linear equations like this. Suppose that the linear equation is, say, a11, a12, let's say x1 plus x2 equals to b1, and then a21 x1 plus a22 x2 equals to b2. And what is the matrix form? In matrix form, how do you write that? You write this one as I can write this one. Another way of the matrix form is you write A11, A11, A12, and then A21, and then A22. Like that. And then you can write this like X1, X2. I'm writing the product matrix form, okay? And then B1, B2. You can write like this. So how do we multiply the two matrices? To multiply the matrix, it is like L, okay? Like A1 times X1 plus A11 times X1 plus A12 times X2. This is like you multiply like this. You multiply like this. A11 times X1 and then A12 times X2. Similarly, A21 times X1, A22 times X2, like that. Okay, so you will get exactly the same thing on the left side, and on the right side B1, B2. Okay, so this is the matrix form, another matrix form of this system of equations or pair of equations. Okay, now we can write this as A and then X equals to B, right? A times X. A is a 2 by 2 matrix of coefficient. X is a 2 by 1 matrix because 1 column 2 rows, right? X1, X2, and then B is B1, B2. Okay, guys, now how do I solve? What is the solution? You need to solve for X. Okay, then how do you write that? X equals to A inverse times B. How do you find out A inverse again? A inverse is that formula. Okay, so what did I do here is I multiply both sides by A inverse. If you do A inverse times A, it is like they cancel out. You can think of it will be a identity matrix. Okay, you will see that. I think you have seen that already in the college algebra. You have taken college algebra already, or you are taking right now. So A inverse times B, if you multiply both sides by A inverse from the left, this is what you get. Okay, so this is how you find out the solution of this equation. Okay, guys, so let us see one example, then you will it will be clear for you. Let me do one example. So example, solve. The equation is given as, let's say, 3x1 minus x2 equals to 8, and then x1 plus 2x2 equals to 5 by using inverse matrix method. Inverse matrix method. How do you solve that? Is you first of all write down that in the matrix form. Okay, what is the matrix form here? You write this is 3, -1, 1, 2. This is like A, right? And then X is x1, x2, and then B is 8 and then 5, right? So where A, this is like A, this is like A, and then this is like X equals to, this is like B. Okay, now, so what does it say? It says that X equals to A inverse times B. We need to find out A inverse, okay? Here A is what? A is 3, -1, 1, 2, right? So how do I find out the A inverse? We need to find out the determinant of A first. That will be 3 times 2. 3 times 2 minus 1 times -1, right? Because this will be the positive multiplication, this will be the negative multiplication, right? So what do you get? It will be 7. So the determinant of A is 7. So what will be A inverse then? A inverse will be 1 over 7, 1 of the determinant, and then you swap these two values, 2 and then 1, -1, and then -1 and then 3. You see that? What did I do is I swapped these values, I switched those values. I wrote 2 here, 3 here, and then I multiply this by negative sign, or you can write change the sign of these diagonal elements. This is A inverse. Now what you want to find is you want to find out X equals to, what is the value of X? Is x1 comma x2, right? Equals to A inverse times B. What is A inverse? A inverse is 1 over 7, 2, 1, -1, 3 times B is 8, 3. You see that? So that will be 1 over 7 we keep. Now I want to multiply these two matrices. So again, if you are multiplying, then how do you multiply? Is you multiply these with that, okay? And then write on the top. Similarly, this with that and write on the second, okay? So how do I do that? Is it looks like 2 times 8 is 16 plus 3 times 1 is 3. You see that? Similarly, what is the another one? Another one will be negative 1 times 8 is negative 8, and then plus 3 times 3 plus 3 times 3 is 9. Oh, I'm sorry, this should be 5, right? This is 5, not 3. So what you get is 2 times 8 is 16 plus 5 times 1 is 5, right? So this one is 5 and this one is 15. You see that? So what do you get? 1 over 7. And then you got 16 plus 5 is 21, and this one is 15 minus 8 is 7. So what do you get is basically, so on the left side you have x1, x2, right? And then on the right side you get, if you multiply each element of the matrix by 1 7, then you'll get 3 comma 1. So it basically x1 equals to 3, and then x2 equals to 1. This is what you get. Okay, guys. So this is how you solve a pair of equation by the inverse matrix method. Okay, guys. So that is the inverse matrix method. All right. So let me write down some definition, because on the solution. So let me write down in this equation, okay, in equation A, let's say, in system A, if B1 and B2 both are 0, then we call the system homogeneous. Okay, we call the system homogeneous. If the right hand side of these both are 0, and then meaning that if the constant terms here are 0, then we call the system homogeneous. Okay, so so the homogeneous system, the graph always pass through the origin. All right, guys. In that case, 0 0 is one of the solution. In this case 0 0 is the solution, but it can have more than that, because if these two equations these two equations have 3 scenarios, right? One is if they intersect at one point, 2 is they are parallel, and the 3 is they have many solutions, meaning that they overlap, right? But since the right hand side is, if the right hand side is 0, B1 and B2 are 0, then this system, these two equations intersect at least at one point, that is 0 0. But they may intersect many points, meaning that they may overlap to each other. Okay, guys. Okay, so this 0 0 solution is called trivial solution. Okay, and called trivial solution. Okay, so let me write down a note here. So look at this. If B1 and B2 is 0, then this matrix will be 0, right? That means this matrix will be 0. In the homogeneous system, what is the homogeneous system? AX equals to 0, right? In the homogeneous system, AX equals 0, where A is A11, A12, A21, A22, and then X is X1, X2. In this system, 0 0 is always a solution. Okay, this solution, or this is a trivial solution, right? This solution is unique if the determinant of A is not equal to 0, meaning it is not singular. If the A is non-singular matrix, then the solution will be unique. If A equals to 0, then there are infinitely many solutions exist. Okay, non-trivial solutions also exist, and they are proportional to each other. If the determinant of A equals to 0, then there are infinitely many, meaning that those two lines overlap. infinitely many solutions. Okay, if you want to think of an example, let's say let's take an example. So what is the type of situation there? Example, let us consider two equations. Let's say x1 plus 2x2 equals to 0, and then 2x1 plus x2 equals to 0. So what is the A, matrix A solution? So matrix A here is basically 1 2 2 1. You see that? So what is the determinant of A? Will be 1 times 1 is 1, minus 2 times 2 is 4, that is negative 3, which is non-zero, right? It is not 0, not 0. So that means this system have unique solution. So it has unique solution. It is not 0, so there is unique solution. Unique solution means only one solution. Okay, so what is that only one solution? If the system has only one solution in the case of right hand side 0, in that case the solution is only 0, 0. Okay, so if the homogeneous system has a non-zero determinant, okay, or if the homogeneous system has a non-singular matrix of coefficient, then in that case 0 0 is the only solution. All right, so let me give you another example that has infinite many solutions. Okay guys, let me take one example of that type. Let me consider example. Let's say x1 plus 2x2 equals to 0. This is homogeneous because right hand side is 0. 2x1 plus 4x2 equals to 0. Okay, so here what is A? The determinant, the matrix A is 1 2 and then 2 4, right? So what is the determinant of A? So the determinant of A is positive multiplication like this, and then this one is negative multiplication. So 4 minus 4 equals to 0. Okay, so whenever this has determinant 0, then there are infinitely many solutions. How do we find out that? Is if you solve this one like in a college algebra way, multiply the first one by negative 2 and everything will cancel out, right? Because if you multiply this by negative 2, let's say by negative 2 times negative 2 times, this will be negative 2x1 minus 4x2, and if you add them you will get 0 equals 0. So in this case there are infinitely many solutions. Okay, but here if you solve this, if you multiply the first one by negative 2, what do you get? Negative 2x1 plus 4x2 equals to negative 4x2 equals 0, right? So negative 2x1 minus 4x2 equals 0, and 2x1 positive 2x1 plus x2 equals 0. So negative 2x1 and positive 2x1 will cancel out. You will get negative 4x2 plus x2 equals 0, means negative 3x2 equals 0. This will implies x2 equals 0, and if you plug in here back, you will get x1 0. Okay, but here that's not the case. So you will cancel both if you multiply by negative 2 there. So there are infinitely many solutions. Infinitely many solutions. All right, so the next thing that I want to do is, what do we mean by eigenvalue? Okay, so I want to basically define eigenvalue and eigenvector. All right guys, of a square matrix.